FastMCP 3 implements a metatool abstraction layer that dynamically exposes tool discovery and execution capabilities through a transform-based architecture. This pattern employs a server-level transform to intercept tool catalog requests, replacing direct tool exposure with discovery primitives that enable progressive disclosure of functionality. The upcoming code artifact will demonstrate how to customize the names of discovery tools and the execution tool within this transform pipeline, illustrating the composable nature of FastMCP's tool presentation layer. You'll observe the configuration of a CodeMode transform that specifies alternative names for the search and schema retrieval tools, while designating a custom name for the workflow execution endpoint. From FastMCP Experimental Transforms CodeMode, import search, get schemas. CodeMode equals CodeMode. Discovery tools equals. Search name equals find tools. Get schemas name equals describe. Execute tool name equals run workflow. MCP equals FastMCP server. Transforms equals CodeMode. This code demonstrates customizing tool names in FastMCP's CodeMode, a pattern for controlling how discovery tools are exposed to clients. The CodeMode transform wraps existing tools with meta tools for discovery and execution, but here we see explicit naming of both discovery tools and the execution tool. The Search and GetSchemas tools are instantiated with custom names, find tools, and describe, respectively, overriding their default names. This allows developers to present more intuitive or domain-specific terminology to clients without changing the underlying functionality. The execute tool name parameter further customizes the execution tool's name to run workflow, making the API more descriptive for the specific use case. This naming flexibility is valuable when integrating with existing systems or when you want the tool names to better reflect your domain language. The trade-off is that custom names create a slight divergence from default FastMCP conventions, which might require additional documentation for new developers. However, for production systems where tool naming needs to align with business terminology or legacy interfaces, this customization provides necessary flexibility while maintaining all CodeMode functionality. Let's break it down. From FastMCP Experimental Transforms CodeMode, import search, get schemas. Imports two transform classes from FastMCP's Experimental Code Mode module. Search for component discovery and get schemas for schema retrieval operations. These enable pipeline modifications during component flow between providers and clients. CodeMode equals CodeMode. Creates a CodeMode instance and assigns it to the variable CodeMode. The line shows the start of a constructor call with no visible parameters yet, indicating a new CodeMode object is being instantiated. Search name equals find tools. Creates a search operation with the name parameter set to find tools. This appears to be configuring a component search or lookup operation within the FastMCP framework, specifically targeting components related to tools discovery or management. The name, find tools, serves as an identifier for this search operation in the MCP protocol context. Get schemas name equals describe. Calls get schemas with a single named parameter name set to the string describe. This retrieves schema information specifically for the component identified as describe in the current context. Execute tool name equals run workflow. Assigns the string value run workflow to a variable named execute tool name. This variable appears to store the name of a tool or operation that will be executed later in the workflow. MCP equals FastMCP server. Transforms equals CodeMode. Creates a FastMCP instance labeled server with a single transform named CodeMode applied. The string server serves as an identifier visible in protocol handshakes, while the transform will modify components as they flow through this MCP server instance. FastMCP3's transform-based architecture enables dynamic tool discovery and execution through composable layers, and this example demonstrates how to customize tool naming within that pipeline. The CodeMode transform acts as a metatool abstraction, wrapping discovery tools like Search and GetSchemas while allowing explicit naming overrides. By assigning custom names like FindTools and Describe, developers align the API with domain-specific terminology without altering core functionality. The execute tool name parameter further tailors the execution endpoint to match workflow semantics, creating a cohesive client-facing interface. This pattern balances flexibility with convention. Custom names improve integration with existing systems, but require additional documentation to bridge the gap from default FastMCP terminology. The transform pipeline ensures these modifications apply uniformly across all components, maintaining consistency while enabling precise control over tool presentation.
The transform whispers new names to every tool, yet the client hears only silence.